Hello everyone, in the last class we have seen the classification of computer based on different categories, and today's class will take up that last class review and will move forward to the lecture number 7, that is on chapter number 1, overview of computers or review of computers by Abidali Sir. So in the last class we have already discussed the classification of computer based on different criteria. The criteria were based on computational methods or type of computers or technology or logic things that they are going to implement, or based on size and the capacity, or based on the purpose what they are used or built for. So based on computational method, type, technology or logic of the computers, we have three kinds, that is digital computer, analog computer, hybrid computer. Based on capacity and size, we have supercomputer, mainframe computers, mini computers, microcomputers and macro computers also. The purpose, based on that, we have general purpose or special purpose computers. So this is what about we have already classified this in the last class. In today's class, we'll see the first kind of based on computational or type of logic they are going to use. There are three main types of computers under this class or section. They include the analog computer, digital computers and the hybrid computer. You will be astonished to see that all these we are been using some or the other way and we are just unaware of they are the type of computers or computational unit. The first thing that we are going to discuss is the analog computer or analog computers. The analog computers are the computers that represent the data or the information in the form of continuous forms, sine waves. See the sine waves, okay, like the waves in the ocean or sea when they are moving, they are in the sinusoidal curve, up and down they will be moving. Okay, so if the information or the data is represented in the form of sine waves continuously, see the mouse cursor moving sine waves continuously, that is called as the analog computer. So that is, there will be no breaks during the signal transmission, continuously there will be a signal transmission. Like for example, when a heart patient is been monitored with the heart rate, you see continuous heartbeats is been signaled, you can see over there. If there is a blank, that means he is no more alive. Similarly over here also, the continuous without any break, if the signals are moving, the data is been transmitted continuously. If the signals are not moving in a sinusoidal curve or sine waves, there is no transmission of the data. So they are representing information or the representation of information by processing the measurable physical quantities is been done in the analog computer. Let us see the example. So this is what I was talking about in the analog signal representation of the sinusoidal curves, that you see the sine waves, they are moving up and down always, has some information 0 or 1 or 0 or 1 they will be representing, but they will not be in the digital format, they will be in the analog format, that is in the form of sine. So there is no break over here, there you can see when the signals are being transmitted. The popular examples that we are using in the analog computers are the speedometers, that is there in your bike, car and etc. That shows you how much average it is giving, or the fuel tank, how much it is filled, or how many kilometers speed you are moving in the bike or vehicle. The thermometer, now you have this, which will be placed in a room, that will be showing based on the mercury temperature, the mercury will be moving up and down. The conventional watches that you see, it's one of the kind of Rolex watch, a very expensive one. The conventional watch, all these are the examples of analog computers that we are using in day-to-day life. Let us move to the next category, that is the digital computers. So these are the computers where the data or the information is not represented in the form of signs, they are being represented in the form of binary, binary digits, that is zeros and ones, what we call it as binary form. So the data and the information in the digital computers is stored in the form of binary digits 0 and 1. So they are representing the signals, that is two states that is on state or off state. The 0 stands for off state and the 1 stands for on state. So it has been representing off stage and on stage. So it is basically the data will be, or communication of the data will be in two states, zeros and ones, combinations. There can be existence of many zeros and many ones, where zeros represents off and 1 represents on. So data is been represented in the binary form itself. Now you see, that's the difference how the sine wave working and the digital computer, that is the digital signals, are going to work. The pit is called as the 0, the up is called as the 1. The pit is called as the 0, the up is called as the pit 0, up 1, like that. So they are in the form of zeros and ones when the signals are getting transmitted from one end of the computer to the another end of the computer. So examples or popular things that we are using in the digital computers are the desktops that we use in your homes. Then we have the laptops which we use in portably carrying the computers. Then we have mobile phones for the communication, all falls under the digital computers, iPad, iPhone, even your scientific calculators that are used in calculating the trigonometrical function or the scientific calculations. So all these are the examples of the digital computers which we are using. The digital computers are again classified into different types. So they are based on the purpose, or they are based on the size and performance wise. Based on the purpose wise, the purpose of the digital computer may be the special purpose computers or the general purpose computers that are used. Now let us talk about the special purpose computers. The special purpose computers are designed to perform a specific task, only that particular task they will perform. So the instructions that they carry out, the tasks are permanently stored in the machine and they are non-volatile. That means they cannot be erased off. They remain permanently. Instructions or the programs or the task what they are built for remain permanently until the unit is working. The best example that we see around us is the blood pressure monitoring system, is one of the special purpose computer designed for monitoring the blood pressure, systolic and diastolic pressure, and even your pulse rate. So here is in the diagram that you can see what the image is. That is a pressure monitoring system, blood pressure monitoring system. Then we have based on the general purpose, not the specific purpose or special purpose. So general purpose computer can work on different types of programs they are getting input to from the user, and thus can be also used in countless or n number of applications. The programs that are not permanently stored, but they are input at the time of execution. But in the special purpose computers, special purpose digital computers, what we can call, the instructions or the task is stored permanently. But here in the general purpose computer, the instructions are not stored permanently or the input is not stored permanently. It can be given when the user wants to execute that particular application or the particular task, and they are kind of versatile. Versatile means the ability of doing many things. So this general purpose computer has the ability to perform many other tasks even. Moving to the next category of computers is the hybrid computers. The hybrid may be combination of analog and both digital. That means these computers exhibit features of analog computers and even the digital computers also. The digital components or the computer's component normally serves as a controller, that is digital part of the computer. serves as a controller and provides logical operations or calculations or manipulation. Whereas or while the analog component or the physical component normally serves as a solver of different equations. Okay, and anybody presses the button, okay, on the system, what will happen? That logical operation and the controlling unit, everything falls under the digital unit, digital component, whereas the normal functions that we do, that is showing the output, everything falls under the analog unit. So it's a both combination of analog as well as the digital component. Okay, you can see over here the best example of the hybrid computer is a automated teller machine, that is ATM machines, what we call. So you insert a chip or a card, ATM card, then you press some buttons, then you enter your pin, then you get the processing. Okay, so there is digital as well as analog units that are working simultaneously together to give you cash out of the bank or the ATM machines. So best example. Then you have electrocardiogram, that is ECG. So when your parents or somebody goes to the doctor, he says I want to take an ECG, or doctor suggests them to take an ECG, that's an how the heart beat rate is fluctuating, how it was over and around some duration, that is called as electrocardiogram. Okay, so that's the ECG that we will be seeing. So this is both combination of analog and digital components. So where the analog component will give you the output, where the digital component will process the equation that is been taken from the heart rate or heartbeat rate. Okay, so this is an example of the hybrid computer. Now moving to the next category or classification of computer based on size or the capacity. The capacity of a computer refers to the volume of data or the information it can process or store and the speed at which it can work. So what we are measuring on? We are measuring on three things, that is volume, then is storage, then it is a speed. Okay, volume, process, speed, okay, or storage, whatever you have, three different measuring unit over here, size and the capacity. So based on this, we are having three main computers, but the general classification goes further around very much in depth. We will be talking in depth even. So there are microcomputers, mini computers, mainframe computers, and even supercomputer falls under the category of the size and the capacity. Let us move to the first one and then see how it is going to affect. So before moving to the first one, let us take a quick review on the computers based on size and capacity. The smaller the computer, speed will be decreased. The larger the computer, it will be performing more expensive or complex tasks, and it will be very much expensive in terms of purchase. So the microcomputer are slow, cheap and simple. Even when you go around, okay, the cost will also increase to mini computer, to mainframe computer, and supercomputer are the fast, expensive, and even it can perform complex or large calculations. So when you come little bit less expensive, not that faster as the supercomputer, mini computer, mainframe computer decreases in the rate of data they process or the volume of data they process, and etc. The first one is the microcomputer that we are going to discuss. They are the smallest of all the computers. The existing of all the computers, they are the smallest. They are also called as the personal computer, PCs. What do you call PCs? PC stands for personal computers, because they are used by one person at a time. Not many people are using it. Not many users are logging in at a time. Okay, such computers are called as the personal computer. Now, what are the characteristics or the main hallmark of this microcomputers? Smaller in size is very small, used by one person, so it is meant for an individual to work, generate less heat, they can fit into any room, required no air conditioning, ventilation is required. Okay, so these are the characteristics. Example of this microcomputer includes the desktops, the laptops, the iPads, okay, and the mobile phones also falls under the microcomputers. They perform some tasks. Okay, so when you go to mobile, they can even read the document, okay, text, perform email operation, all those things they can do. Okay, then you move to iPad, more complex, then you move to laptop and the desktop, they perform the more complex operation than considering the mobile phone. Then you have the workstations. This also falls under the microcomputers. What are the workstations? When you want to work on more than one different applications at a time simultaneously, though even the operating system performs you multitasking, but you want all the tasks to be shown on to your computer, then you will use a workstation. So this is a workstation made for multitasking, where basically this type of workstations are used by the ethical hackers or the cyber polices, or even for monitoring the security of the banks or other systems where many tasks are being performed at a time. So this is a chair which performs the complexity to sit and perform certain operations, which you can see in the diagram. So then we have the mini computer. That's what we will be discussing. The last part of this lecture video is the mini computer. The mini computer is the one whose size, the speed and the capacity lies between the macro computers and the microcomputers, in between them, both of them. Then we have the mini computers which are larger and more powerful computer than the PCs that we are using now, the personal computers. What are the things that they can do? The mini computers could execute, or it can execute up to 5 million instructions per second. How many lines it could read and interpret? It could read and interpret 5 millions of instructions per second. So that's the capacity of the mini computer. And you can see in the diagram, there are series of mini computers that you have, which was an example as VAX 8800 series, an older mini computer, not today's generation or the 4th generation one. Then you have AS400, different series or models which are developed by IBM application system, falls under the 400 family, AS400 family. Different models are available. So these all are the examples that are used in the mini computer, much more powerful than the personal computers that we are using in our home. Now where they are being used? They can be used in an organization where the data processing is required, or the larger data, like for example processing of the Aadhaar card numbers, or processing of the telephone industry, or switching circuits between one line to the another line, or different areas they can be using. So the next class will move to the mainframe computer, and we will talk about the mainframe computer and where they are being used. Okay, thank you for watching the video.